Welcome, everyone. It's great to see so many of you joining us for this fourth forestry speed dating webinar focused in this season on wildfire solutions and innovations, which is a collaboration of the Bioregions Facility based at the European Forest Institute and the Fire project. My name is Anne Ackermann. I am located in EFI in the same team as the Bioregions Facility, but I am also representing the Fire project side of things today, and I will be facilitating this webinar. And to just set a little bit of context, I think I would like to recall to everyone's attention how wildfires are increasing across Europe and beyond, for that matter, and how they are also increasing in areas previously unaffected or less affected by this phenomenon outside, for instance, the Mediterranean basin, and causing, I admit, and we admit in the project, some positive outcomes, but also a lot of potentially very negative impacts on societies, on the environment, and also economic losses. And one of the kind of very insightful and impressive statistics is from the Copernicus European Forest Fire Information System recently, that the burnt area in 2024, for instance, has been at a level of about 10% above the average of the past 20 years or so. There has been a 60% increase in the number of recorded fires. So we can no longer hide away from the fact that this phenomenon is increasing and causing all kinds of negative impacts that need to be addressed. And we feel, as part of the project, as part of EFI, that fostering coordination, collaboration, and knowledge exchange across sectors is essential to address this issue. For this reason in particular, we are really pleased to see so many of you here today. Because collaboration is needed to address this issue and to come up with solutions that are efficient and effective at mitigating the risks caused by these fires, we host these forestry speed dating webinars because we believe that fostering innovation and creating platforms for finding collaboration partners is key to promoting the valuable work that you are all doing. The forestry speed dating series is only possible because of the generous support of our member regions. And I would like to briefly meet them here. The Basque Country, Catalonia, and North Rhine-Westphalia are our current member regions. And I invite you to learn more about these regions, if you like, from the Bioregions Facility website as well. Also, as I said before, today's webinar is the result of a collaboration with the Fire project. Fire is a Horizon 2020 funded project that focuses on enhancing wildfire resilience by developing and implementing innovative solutions. Our two presenters here today are both participants in the Open Innovation Challenge hosted by Fire last year and have been part of an acceleration program that we offer for these participants. Now, it's time to meet our innovators who are presenting today. We have solutions from Portugal and Greece, and the companies or innovations we're talking about are Prevent from Hephaesnus and TYPHOON, the firefighting system.
So good afternoon, everyone. My name is Amaro Martins, and I'm the CEO of Hephaesnus. We are a young startup based in Portugal, and we are essentially an R&D company that develops new technologies and products for a safer, more efficient, and autonomous forest firefighting. A short note before we start, we have previously announced that we'll be presenting the Prevent solution. Now there is our internal or more technical name that we attribute to our product, which will be presented here under the commercial name Guard. So they are the same product. Just in case if you notice a slight difference in the names, it's just because we attribute one definition to the internally to the product and another one for commercial purposes only. All right, so as Anne also said, I'm a repeat offender on this. And just to briefly explain, this is perhaps why we are an R&D company. We develop several technologies to fight forest fires. And today, as I've said, we will be presenting here so prevent/salus guard solution. So just to provide you a bit of a small context, in 2023, which is the last year we have full data available, there were almost 1 million fires around the globe. And the number of large forest fires is dramatically increasing. So huge calamities such as the fires that happened in Pedrógão Grande in 2017 here in Portugal, which killed over 80 people. If we thought that would be a one-time type of event, now we could not be more wrong. Just in the last year, the small town of Jasper in Canada was completely destroyed by a nearby forest fire, causing damages to over 300 houses and structures. However, this type of forest fire is not just destroying our forests and small assets, it's also destroying high economical value. These are just two of the latest examples that we found that happened here in Portugal, but this example can replicate hundreds of times across the globe. And as we've seen, the recent fires in Los Angeles have shown that large forest fires are sadly here to stay. Now, we at Hephaesnus developed a solution that will be able to tackle the damages caused by these fires. And for that, we've created Salus Guard. Salus Guard consists on an ornamental exterior vase, which is able to both detect and fight a forest fire in a fully autonomous, independent way. So whenever there's a fire that is coming nearby the vase, so imagine that you have a fire here, our vase will be able to detect it, launch an alarm, and launch our innovative retardant load onto the fire and avoid the fire from progressing and destroying your asset. So in essence, this is a barrier against fire progression to destroy any type of economical or high valuable asset. This allows our clients to establish a safety perimeter. It is an ornamental and of premium value because people can actually have some value while they don't have any fires, because they can put plants on it, they can add lighting solutions, CCTV, amongst other things. And of course, we've already patented our novel retardant load and patented our design, so that design you're currently seeing is already protected. So in case you're just wondering how it really works, here's just a very small video demonstration of how our technology works. So usually when the fire is detected, there's a small delay, which is what you're currently seeing. And then our retardant load is released in a pressurized, controlled way. It's pretty much like a sprinkler system, only better. So in this case, what you're seeing, we just filled our pressurized tank of up to only 30% capacity. Otherwise, we would be sitting here for roughly 3 minutes just watching the effects of that. However, as you can see, and it only released a couple of liters of our retardant load, you can see that the floors are already completely wet, and it would be already impossible for any fire to progress, at least from its base, onto our client's properties. Now, regarding our main market advantages. First of all, our vase does not require any connection to electricity or water mains. So it does not require any complex works in order to install it. It does not require any wires, and it does not require any sort of external connections to it. So even if there is a fire and if there is any lack of power or water, our vase is fully covered because it already has both. It is always active, so it's active 24/7, so it's always with you. It provides a full protection of wooden structures because we can actually also turn the vase onto the wooden structure and ask it to sprinkle the whole wooden structure and protect it, because that way the wood would be covered by our retardant load and the fire will not be able to burn it or destroy it. Then this is also a fully autonomous vase, as I've said, so it does not require any type of human intervention. The only exception is if any human is actually afraid that the vase may not work, we have an emergency button that humans can press it if they're evacuating or if they really want to do it. And of course, this is a product where you actually can have some added value to it. This is not a simple fire detector. This is much more than that because it actually provides protection even if you're not at home, and you can actually have some use to it while there's no fire by putting up plants or adding other extras that we have available at the moment. Just so talking a bit about our competitors, and I believe you may know them. So the first of all, which is really common in North American countries, so the US and Canada, we have sprinkler systems, which are usually placed on top of the roofing of houses. However, these have a few constraints. The first of all is that they usually imply a high cost. The other is that they require a permanent connection to water and electricity systems, which many times is not available during a fire. At least in many European countries, the electricity systems are usually placed on rural areas as well, around forests. So if there's a fire in a nearby forest, it's a lot likely that the fire has consumed the power lines and that therefore there's no electricity. And if there's no electricity, there's no water, so the system is rendered useless. And therefore, because of this, it has a dwindling cost efficiency. Then we have sort of new technologies that are coming up on the market, which I'm pretty sure you also know them. And I'd like to just mention here the fire sensors. I just mentioned a couple of brands here, which are really popular on the market right now. However, these usually have a high implicated cost, not just because of the price of the sensor, but also of the price of the gateways, servers, and communications that are incurred on the client. And because they can be complex in that sense that they need a physical space to establish the server, etc. So this implies high cost and unavailable space. These only detect fires and are only able to do that and inform the client that there is a nearby fire, so it doesn't actually fight it like ours do. And again, it requires a connection to complex IoT systems, which are expensive and sometimes even require maintenance. Regarding our roadmap, this is essentially just to tell you that on the last year, we were fully developing the product and we were just doing the last software tests. Right now, we are doing our pre-launch and we are incorporating alongside a major telecommunications company. We are incorporating a communication module, which will allow the clients to receive text messages regarding the status of the vase and if there's a nearby fire. And we hope that towards the end of the year, we'll be able to internationalize our product to Spain. So by the end of the year, we should be able to be present in both Portugal and Spain. As for our team, the Hephaesnus team is very young, but highly multidisciplinary with a few PhDs on the team. And obviously, we are a team which is completely dedicated to developing new technologies to help fighting forest fires in a safer, more efficient, and autonomous manner. Last but not the least, I'd like to ask you to join us in a change in fighting forest fires. And as kindly requested, today we are currently seeking here we're looking for either an investor or potential clients for this type of technology. Thank you.
Good afternoon to everyone. Thank you for your attention. My name is Fivos Koukouvinis. I'm assistant professor in the Laboratory of Thermodynamics in Cyprus University of Technology. And in the presentation that I will show you today, I would like to show some developments, the concept idea, tests that we have done, and future directions that we envisage for the TYPHOON firefighting system. I would also like to mention here the team behind TYPHOON. Okay? Apart from my side is also John Anagnostopoulos and Dimitris Mathiulakis from the National Technical University of Athens, and John Krekoukis from the actual company manufacturing this particular system, TYPHOON Firefighting Systems. So, to start with a small introduction, a bit of statistics, something similar you have seen before. The wildfire hazard is increasing over the years. You can see it in this graph over here. The wildfires over the years are these brown lines, and there is a clear trend of an increasing number, both in terms of number of fires, the area affected. So, okay, it is a global effect, and there are possibly many reasons to that, including global warming, but we need to be able to tackle this issue. Apart from wildfire hazards, there are many other scenarios. I present here some indicative residential fires, for example, industrial fires, fires in confined spaces like trains or planes, and also an emerging challenge that we have is battery fires and electric vehicle fires, which are quite problematic as well. The reason why I'm saying all this is because we need innovative solutions to tackle all these cases, and we need flexible systems. Some background in terms of the trends in firefighting systems. We have the water mist systems that have been established as firefighting solutions. At the top, I present some indicative examples from recent, let's say, developments. But all such systems are very, very bulky. All such systems employ axial fans that are very large. Effectively, they are limited in their way of operation. This is the main advantage of the TYPHOON system, which you can see at the bottom right part of the presentation slide. It is a system that we do employ water mist. We have a very powerful fan, but it is also a very lightweight fan that allows us to put it on top of a crane. And this gives a lot of flexibility and the capability to use the system in a large number of scenarios, and moreover to have integration of automation and remote control. So the concept behind TYPHOON is aimed to address both specialized equipment and solutions and integrated large-scale coverage for forest monitoring. Some indicative characteristics of the system: it is a crane which has a fan, and with this fan we can generate a water mist. The crane is entirely remote controlled, so you can control it outside of the vehicle. The whole system is self-propelled. It has two different engines, one for the vehicle itself and another one for operating the firefighting system. The power is transmitted through hydraulic means, and in terms of the fan, it is based on a centrifugal blower. To give an example of the flow rate, it is adjustable between 6 to 15 cubic meters per second. This corresponds to an airspeed of up to 700 kilometers per hour. It has a power rating that can range from 100 to 600 horsepower. In terms of water, we can use an adjustable amount of water, and it can go from 0 up to 0.1 cubic meters per second. And the key innovation of the system that you will not find in similar solutions is that it can work with water, firefighting foams, or fire retardant foams, anything you want to use it with. Some characteristics of the crane: it is a fully articulated arm. It has 5 degrees of freedom, so you can see in this graphic depiction at the top left, it can move at 3 directions and it can rotate at 2 directions. We can adjust the characteristics of the water mist spray, so the width, the angle, and the range. And to give an example of the range, we can reach up to 50 meters in the case of adverse wind, and it can go beyond 100 meters in case of favorable wind. And something else is that we can mount a tube at the end of the fan, as you can see at the bottom right image, in order to direct the jet in enclosed spaces or whenever it is needed. An indicative depiction of the capabilities of the crane are also shown here. So it can reach up to a height of 15 meters. So you can go up to 3 stories, for example. And it has a radius of reach of almost 11 meters. We have done quite a lot of analysis in order to reach this level of maturity. So I wouldn't like to tire you with all these details, but we have done structural analysis for the crane because the blower creates quite a lot of loads. Detailed finite element analysis for all the crane and to dimensionalize piston and hydraulics, and also decide on automation and control of the system. Similarly, applies for the fan. Again, the desired characteristics were 6 to 15 cubic meters per second, aiming to achieve a top airspeed of 600 to 700 kilometers per hour. Ideally, we would like to operate in 3,000 to 4,000 RPM. And the key advantage of our design choice is that by using a centrifugal fan, we can achieve a very high power density of the system, which means that we have a lot of power that is in a very lightweight and small package. Again, the fan has been extensively optimized in terms of all its characteristics, like number of blades, angle of blades, width, and size of the rotor. And we have achieved an efficiency of 65 to 70%. Similarly applies for the structural aspects, because in terms of structural, let's say, soundness, and it is quite demanding to devise a blower that is lightweight and at the same time structurally sound to be able to handle the loads. In the end, we have achieved a structural capacity up to 4,200 RPM and 600 kilowatt of power of the blower. And all this within 75 kilograms of weight. Okay, I would like also to show some indicative images during the manufacturing and the assembly. We have done extensive testing of the blower on its own. And I can also show here a video how the system looks like when it is operating. So here is the blower at the end of the crane, and what you see is the water mist as being generated by the water being injected at the outlet of the blower. So, to highlight the advantages of this particular system, since it is a water mist-based system, it has a lower water consumption and a better efficiency compared to the traditional water hose systems. The use of a very powerful blower can allow a very large volumetric flow of air, and with this we can both remove heat loads and also evacuate smoke from confined spaces. We have done tests recently which illustrate that only by using air we can reduce heat loads, and this is what is illustrated at the right part of the image, where we have done measurements with a thermal camera. On top of the above, we have also a large flexibility because we can adjust the position of the blower and we can attack the fire from different angles. This allows a great flexibility in the types that we can face. It's not just forest fires, but we can also address urban fires, industrial fires, fires in confined spaces like trains or planes, and anything else. For example, specialized fires that may require a different firefighting solution, like water, like fire retardant, not water. It is a remote controlled system, and something else is that it improves operational condition and the safety to firefighters. In the future, what we would like to do is additional diagnostics, like integrate infrared cameras, more automation, so the whole system to operate autonomously with less intervention from humans, integration of robotics, and possibly integration of swarm systems with UAVs and UGVs, improve telecommunications, and improve the remote controlling to the complete vehicle. So in its current state, we have a remote control that you can see at the top right of the image, and this is just for the crane. Ideally, we would like something similar, but for the complete vehicle. And we would like to advance the system from a TRL level 6-7, which is currently being as a technology demonstrator, to a TRL 9 for a final solution and an end product. Closing, I would like just to mention the latest advancements. Okay, you are aware that TYPHOON system is a selected solution in the Open Innovation Challenge. On the 25th of January of 2025, we have done a demonstration of the TYPHOON system in collaboration with volunteer firefighters. And also there were representatives of the Wogland Fire and Rescue IKS. They have seen the system in action, in operation, and they have recognized that it is an innovative solution to modern firefighting needs. So ideally, what we are after is collaborations for all aspects of the product. Adoption, testing, potentially also advising and investing on the vehicle. So that is all from my side. Thank you for your interest.